Okay, so let's jump in here at the bottom of page 200. We're going to do number 9 together, and then you guys are going to go back a page and do a similar problem and then some other group work. And then after a little bit of doing this section that we started last class, then we'll jump in and do a new section today. Now, it's been a while since we covered this new material. Last class we had our test. The class before that was advising day, so there were no day classes. So it's been about a week and a half since you guys have thought about this section. So jumping in here at number 9, we've got this complicated equation, w minus ty over 3 minus r equals z, and we're trying to solve that equation for y. And again, what makes this complicated is that there are many variables in there as opposed to just being a single one. Come on in. So the goal is to solve for y. I'll just circle that in red so that we can really focus our attention on that thing. And our job in plain English is to move everything away from that y. One piece at a time, everything has to go away from the y so that we get y by itself. Now, there are a bunch of things on the left-hand side near the y. There's a w, there's a t, there's a 3, and there's an r. The equals z doesn't bother me. It's already far away from the y on the other side. There's only one of those pieces I just named that is accessible to us, that is ready to be moved over to the other side. The w, the t, the 3, or the r. Which one is just kind of hanging out on its own? Is the r. That minus r is not part of the fraction, right? So we're going to move that r over to the other side by doing what to both sides? Let's add r to both sides. The fraction is still here on the left. The right-hand side is now z plus r. And it doesn't combine, doesn't go together. So that's it. Again, I'll circle the y. That's the thing we're trying to get by itself. So everything else needs to move. We have 3 pieces nearby the y. And again, only one of them is really ready for us to move to the other side. Is it the w, the t, or the 3? It's the 3. So how are we going to get rid of this division by 3? Multiply. So multiply both sides by 3. And then we'll copy what we have. On the left-hand side, the 3's cancel. Don't distribute that 3 on the top. It's not there. It just, you put it there so that you can immediately cancel it. And we just get the numerator, w minus ty equals. And then I'll just copy this thing on the right-hand side. What I've written here is not right. What mistake did I make? What do you mean, Jessica? What does it look like I've done? Yeah, it doesn't look like I've multiplied the whole right-hand side by 3. It looks like I'm only multiplying r by 3, right? Right there. The r is the only thing touching the 3, but it should have been the whole side times 3. So really what I should have included or should have added is parentheses. Well, why was that different than on the left-hand side? I didn't need to put parentheses here. It's because it's implied, right? It's a fraction. It's implied that it's one thing. So we didn't need these added symbols. Okay, that's good. Again, I will circle our friend, which is the y. There's still 2 things near the y that need to move. The w and the t. Which one is free, accessible? It's the w. It's far away, so let's move that to the other side by doing what? Subtract. So we'll subtract w both sides. And let's see, what do we get here? So we get minus ty equals z plus r times 3 minus w. We're on page 200 right now. Okay, and then one last time, circling the y. The only thing nearby is that minus t. How do I move it? Do I add t to both sides? We divide, because right now it's a t times. So we divide both sides by minus t. And basically we just have to copy the answer. Y equals that whole mess on the right-hand side. Okay, So solving these equations, it involves the same techniques that we've been developing this semester. They just look more complicated because there are a lot of letters there. But I'm a fan of this: circle the only one that you care about and then move the other pieces over one at a time. Just got to do it in the right order. Grab whatever is most accessible and move it to the other side. Okay, so the first part of this course, maybe first part of today, I should say, maybe about 20 minutes. You guys are actually going to take a step back one page. You should have filled in, let's see, where are we here? Take a step back 3 pages, actually. We're going back to page 197. Okay, so with your neighbors, you guys are going to do number 6 right now. Check in with each other as you do that. And then you're just going to continue on to the next page, which involves using some geometry formulas that you may or may not be familiar with. But work for about 20 minutes, get as far as you can, starting on page 197 with number 6. I'll put the flags out if anybody gets stuck. So I'm back here on page 198. Just to give you a process, and this is a table that you'll see a bunch of times in the coming classes. I'll give it to you on the, like any quiz or exam that you need to use it. I will provide you all of these formulas. But I want to make sure you're really clear on exactly how to find stuff. So the first thing I would do for any problem related to these geometry things is figure out which shape we're talking about. So right here is the list of all the shapes: sphere, cylinder, cone, and pyramid. Those are the 4 shapes that I could ask you about. There is one that's not in this list. I'll write it up here, but a box. Let's see, you guys are about to be amazed by my 3D drawing ability. Isn't that just fantastic? So I expect that you know the way to find the volume of a box. What's that formula? Length times width times height. And I expect you could find the surface area of a box by just taking the 6 different faces, find the areas of each of them, and then just add them all up, right? Every rectangular face is just the length times width, and there are 6 faces. So you just need to add them all up. So the shapes that I'm going to give you are these 4. But there's one other shape that is conspicuously absent from that table, which I expect you know how to deal with, and that's the box. All right? But these ones here, let's see. So the first one was a beach ball. So your first task is to figure out which shape is a beach ball. So a beach ball is a sphere. We know that. And then you got 2 kinds of formulas. And every problem I give you with the geometry stuff is just going to be one of those 2 formulas. It's either a volume or a surface area. Now, if I were a nice guy, I would just say the volume of the beach ball is, or the surface area of the beach ball is. But you know I'm not a nice guy. So you have to read between the lines and figure out whether it's a volume or a surface area. So this one right here, the keyword is filled. If you fill something, is that a volume or a surface area? It's a volume. So as soon as you see that keyword filled, you say, oh, it's a volume. Sphere, volume, it's that formula right there. And we use that formula. And other kinds of problems, like down here with the tent, the key phrase was amount of canvas. Is that a volume or a surface area? That's a surface area, because I'm telling you how much stuff goes around the outside of the pyramid, right? And so I'm not just going to say plainly this is a surface area, but you have to know what the keywords are to look for. Other things that have to do with surface area would be like painting. I tell you how much paint it takes to paint around the outside of the shape, or wrapping it up like it's a present. Any kind of thing like that is a surface area, but filling it is a volume. The other thing that might be a tip-off is the units. If I say square feet, am I telling you a 2-dimensional thing or a 3-dimensional thing? Square is 2, and you know squaring something means 2. So if you see square feet, that's the 2-dimensional thing. Volume or area, which one is 2-dimensional? Is area, right? So if you see a square feet calculation, there's an area going on. But down here with the beach ball, let's see. Well, actually, so this one didn't help because I didn't give you the volume. But what was your, I don't know if you wrote it, but what was your answer here? This was the radius. What was it? Not the radius, the volume was, what was it? 4188.79. And then what are the units? It's a volume. Right, so this was inches was the unit of this one. That's what the diameter was given, but it's a volume, and volume answers are 3-dimensional things, cubic inches in this case. Okay, so a little bit of practice with the tables, and hopefully you'll be quite comfortable with them. You see them here again. And the right-hand column, by the way, is just a list of all the different letters that appear and what they mean. But let's move on to page 201, and we'll start with the objective. Tyler, can you read the objective, please? Thank you. So let's take a look at number 1, which says solve 108 minus 3u squared equals 100. Now, it might kind of feel like a breath of fresh air if this equation is less complicated than some of the ones you solved 5 minutes ago. There is one new thing, which is why we're tackling this today. What's the new thing in this equation? The variable is squared. This is the first time all semester where we have solved for a variable that was squared. Okay, so let's see if we can tackle that. I'm going to circle in red. I'm not going to circle just the u, but I'm actually going to circle u squared first. Ultimately, I need u by itself, but let's just see if we can first get u squared by itself. So of the 108 and the 3, both of which need to move, which one is available? The 108. So let's move that 108 by doing what? Subtract 108 from both sides. So we get minus 3u squared equals negative 108. I'll circle that u squared again. Okay, still not worrying about the square part, but just getting that negative 3 out of the way. What do we do? Divide both sides by negative 3. Without a calculator, do that division. I get 36. Is that okay? All right, so we get this answer. U squared equals 36. Okay, that's not so bad actually, because you can think of a number that when you square it, you get 36. What is that magic number? It's 6. So just kind of by looking at it, without really thinking about like a mathematical procedure, we can just say, oh, the answer is 6, because 6 is the magic number that when you square it, you get 36. So U equals 6. So I'll put it down here. I'm leaving a little space because in the space we're going to fill in, you know, like there was kind of a miracle that just gave us there. But I'll give you like a procedural thing you can do in case the miracle doesn't happen. So we get U equals 6. Are there any other numbers that have that same property? That when you square this other number, you still get 36? Now, if it were 4, then 4 squared would be 16. Are there any other numbers that when you square them, you still get positive 36? Let's try negative 6. Let's just try. If I take negative 6 and I square it, right, because that's saying take the number and square it. So I think I'm justified in putting these parentheses even though they weren't there to start. Okay, well, what does that mean? It means negative 6 times negative 6, right? And it's positive 36. So all of a sudden, for the first time all semester, there are 2 answers to an equation. U equals 6 is one of the answers. And U equals negative 6 is the other answer. 36 were negative. Oops. It said U squared equals negative 36. So if you multiply 2 positive numbers together, like you square something, what happens when you multiply 2 positives? What kind of a thing do you get? Positive. What if you multiply 2 negatives? It's still a positive. So is there any way to multiply a number by itself and get a negative? No, at least not this semester. The answer to this equation, the solution to that equation, is not a real number, but maybe in some past, what happened there? In some past math class, you saw imaginary numbers, I. We won't tackle them this semester, but you'd have to leave the real numbers and go to a bigger number set in order to have a solution to that. We won't have it this semester. All right. Okay, so let me fill in the gap here. So what are we going to do? Well, this says U squared, and we're trying to get U by itself. So somebody took our poor number, the U, and they squared it. So we need to undo that. What's the opposite of squaring something? Is square rooting it. And so that's what we're going to do to both sides. We're going to, like, it's kind of strange. Square root of a number you guys just know, like square root of 81, you just know is 9. But now we're going to take the square root and kind of treat it like a verb, like it's in action. It's something that we can apply to an equation. So I'm going to write that equation again in black. And then I'm going to actively put in blue a square root symbol around both sides. I'm going to take the square root of both sides. It's no different from adding 5 to both sides or multiplying both sides by 3. As long as I do the same thing to both sides, it's legal, it's legitimate. So we're going to take the square root. That's how you get rid of a squared. So if we buy that the square root and the square cancel, then they just disappear. Now don't cross them off because they don't, well, they kind of cancel, but they don't really. But if I do just cross them off, then I just get u equals, and then what is the square root of 36? It's just 6, and I'm still missing this other solution. So I said don't cross them off because they don't quite cross off. So here's the deal. Important fact for right now, square root of u squared, it feels like they should just cancel, the square root and the square, and you should just get u. It turns out the full answer is absolute value of u. The square root of u squared isn't just plain old u, it's absolute value of u. I'll give you 2 quick examples here. Square root of 7 squared. 7 squared is really 49. And the square root of 49, you know, is 7, no problem. But what if I gave you this? Negative 7 squared. It's still 49, right? Because negative 7 times negative 7 makes positive 49. And then just looking at the square root of 49, you still know that's 7. So whatever number was in there, 7 or negative 7, it became positive 7 at the end. Do we see that? Like whether it was 7 or negative 7 at the start, they both became positive 7. So what's the thing that takes a number and makes it positive no matter what? That's the absolute value. So I'll put some stars around this formula here. That's what we're going to use a bunch today. So coming back over here to this blue square root symbol, when I took the square root of u squared, I feel like I should just write u, but it's actually absolute value of u.
So what is that?
Yeah, absolute value, you have to put those lines in. And now this is a miracle, but it's a smaller miracle to have. The absolute value of some number is 6. There are actually 2 numbers that work. What are the 2 different numbers that have the absolute value equal to 6? 6 and negative 6. And so that's kind of filling in the gap to get us to our 2 answers. That's the 6 and the negative 6. The only other way that I have is also a miracle. It just says if you are solving a squared equation, you're going to end up with 2 different answers in it. And this semester, they're always going to be plus and minus the same number. But it's not compelling, and it's so easy to forget. And so my recommendation is that even though this feels complicated, and this new formula here in purple in the top right looks strange and weird, with a little bit of practice, it becomes more natural. Last thing I'll say, but this is only going to help us in certain cases, if you have an equation with a u squared in it, there are going to be 2 answers, the 2 matching the power. I'll say it again. Any equation that has a squared in it is going to have 2 answers. That highest power right there tells you how many answers there are. Many equations we solved this semester, what's the highest power on the x? 1. How many answers have we gotten all semester to equations? 1. Whatever the highest power is, that tells you how many solutions there are. So if you see a highest power of 2, the very first thing you might know is, okay, I'm going to expect 2 answers at the end, and just make a little note of it. The problem is that even though it's still true, if I gave you like u squared equals, u cubed equals 64, how many solutions do you guys think this equation has? This equation has 3 solutions, and it's true. Whatever that highest power is how many solutions you're going to get. The problem is that this semester, even if I ask you to solve equations like u cubed equals 64, I'm only going to be asking you for one solution. Can anybody have a miracle and tell me what's the number that when you cube it, you get 64? The absolute value doesn't come in on this one. What's the number that when you cube it, you get 4? Sorry, you get 64. It's 4. So that's one answer. But how many answers did you say there are? There are 3, whatever the highest power is. This semester, we're not going to be looking at the other 2. So like I can't even say to you, look at the highest power, that's how many answers you're going to get, even if it's true. What I'm saying is a true statement. The highest power is how many answers there are. But this semester, in this class, u cubed equals 64 has only one answer, and there are 2 others that we aren't going to bring in.
So when you say you're only looking for one answer, is one of those 3 answers acceptable?
Yes. U equals 4 is one of the 3 answers.
And any of those answers would be okay? Or do you want?
Any of them will be okay, but trust me, you're not going to find the other 2. Yeah, not this semester. Okay. All right, let's move on to number 2, and then you guys will have lots of time to do group stuff. Let's go to Marcy. Could you read number 2, please? Yes, please. Okay, let's give this a shot. First task, figure out which shape it is. Your choices are sphere, cylinder, cone, or pyramid. I was really nice in this one. What shape is it? Sphere. Spherical sphere. Have to pick either volume or surface area. How do we know it's a volume? There's one key word in here. Cubic is useful, absolutely. If you see cubic, it's a volume. For me, it's the word holds. That tells me how much stuff is inside, which is a volume. So that tells me volume, and so the first thing I'm going to do is write my volume equation. I'd encourage you to copy it just as it is. I know it's tempting to just go right in and start plugging numbers in, but just write that formula as it is initially. I'll give you points for it on a quiz or an exam. Okay, so now we have to plug some stuff in. Instead of looking at the equation and saying, okay, what's V and what's R, I think it's better to look at the problem, find the numbers, and then fill them in where they go. So 42,387 cubic inches. It's either V or R. Which one is it? It's V. It's holds. That's the volume. It's a cubic thing. It's still volume. So let's just write the number instead of the V. Okay. So we are going to solve this equation for the only letter that remains, which is the R, which is kind of good because it said find the radius, so everything is set up appropriately. We have a 4/3, we have a pi, and we have a cubed. We got to get rid of all those things because we need the R by itself. Again, I'll circle it. Do we have a sense? 4/3 and the pi are kind of equal to each other. They're right next to each other, and the cubed is a different thing. Only one of these is ready to go to the other side right now. Can you tell which one it is? Could be the cubed, could be the 4/3 pi. I mean, one of you guys is right. So it's about the order of operations. I'll write our little mnemonic here on the side. MDOS. So the 4/3 pi or the cubed, which is the higher priority in terms of order of operations? Is the cubed, because we know exponents come before the multiplication. This is the arithmetic order of operations. But when we're doing algebra, we know we're going the other direction, right? So if we do arithmetic and exponent comes before multiplication, then when I do the algebra, we got to undo the multiplication before we undo the exponent. So that's what we need to do first. So we'll divide both sides by, how about we just do it all in one fell swoop? 4/3 and pi. It's all times, so we make it all division. Both sides. Okay, I'm going to copy the left-hand side, even though it's really complicated. 42,387 divided by 4/3 pi equals, what remains on the right-hand side? r cubed. Because we cancel the 4/3 and we cancel the pi. Okay, so the goal is to get r by itself. Currently r is cubed. What's the opposite of cubing something? Is cube rooting that thing. Cube rooting. Just like in the previous problem, we were at this stage right here. It said u squared equals. Somebody took our u and they squared it. So to undo that, we took the square root. Same thing down here. We're going to take the cube root of both sides of this equation. I'll put that in green. Cube root of this side, cube root of this side. I just want to highlight we are doing exactly the same thing to both sides, which is pretty much one of like the two most important rules in algebra. Just do the same thing to both sides. Hardly matters what you do, as long as you do the same thing to both sides. So cube rooting both sides is legit. I'll copy the left-hand side. It's as complicated as it's going to get. Equals. Okay, cube root of r cubed. We took the cube root because it was the opposite of cubing something. So the cube root of r cubed becomes what simpler thing? It's r. That's the answer, and then we're going to type it into the calculator. I want to point out one other difference between this problem and the previous one. When we took the square root of u squared, what did we write? Absolute value of u. So it feels like I'm missing that because we took the cube root of r cubed, and it seems like absolute value belongs here. It doesn't. It turns out that the absolute value only makes an appearance when the thing you are doing involves an even number, like square rooting involves the 2. Even number things give you absolute value. Odd number things don't. The fact is, I'm not going to give you anything other than squares and cubes in this class anyway, so you don't really need to memorize this whole even odd thing. You just need to know, if you square root, that's where the absolute value comes in. If you cube root, it doesn't. Okay, so last thing is to type this thing in very carefully. So I'll do it here. Your calculator might look a little different, but that's okay. Okay, so on my calculator, the cube root button is inside of math. It's right there, number 4. Now you guys, I'll walk around in a second and help you find your cube root button, but that's where mine is. 42,387 divided by, the next symbol I type is really important. What's the next symbol? It's parentheses, because that 4/3 pi is one thing. So I need to tell the calculator that 4/3, 4 divided by 3, pi is one thing. That's good. Close parentheses, and I think whatever we get is going to be our answer. Tyler? Let's talk after class. Okay. I get 21 and change. This number does not seem right. 42,000, 10,000. What did you guys get? Actually, maybe I'm feeling okay about my answer. If I take 21.6 and I cube it, I'm hoping, what's wrong with this thing? 21.6 and I cube it, then we should hopefully get something. Yeah, all right, I'm feeling good about my answer. 21 and change. Okay, so here's what's going to happen. I will walk around if you did not get this on the calculator and help out while you're waiting for me. Move on to the next page and do the classwork stuff for the rest of this class. 20 minutes.